Now we will perform parallel operation of two single phase transformer. In subsequent what we have done back to back test for two similar transformer, that is both 1 kVA transformer. Here what we are doing in parallel operation, we are using two different transformers. First one is power rating is 1 kVA and other one power rating is 2 kVA. Two different power rating transformer we are conducting parallel operation. For that, as usual, the nameplate details is type is single phase. Type is single phase. Capacity you have to write both 1 kVA, 2 kVA. Both you have to write. Voltage 230 volts only. It is single phase. Current you have to calculate. Frequency 50 hertz. Current already you have calculated using that formula. So 1 kVA equals 1 second. We will calculate. IS current IS equals VA by kVA by VA. AA will cancel. IS equals kV is 1000 divided by 230, that equals 1000 divided by 230, 4.34. First one 4.34 for 1 kVA. 2 kVA it is 8.69. Same way you have to do, instead of 1 you have to do 2000 by 230. You will get 8.69 amps. Here also you request voltmeter 0 to 300 volts one and 0 to 600 volts one, and 2 ammeters. One is 0 to, one more ammeter, sorry. So pause madam. Yeah, here 3 ammeters are required. 1, 2 and 3. One is 2 is 0 to 15 amps and one is 0 to 2 amps, because one ammeter will be in parallel, so one it will be, current will be divided. So I can, one is 0 to 2 amps is enough. Coming to circuit diagram, here is the single phase supply with two different transformers. This is 1 kVA transformer and this is 2 kVA transformer, and here 1 ammeter and here 1 ammeter. 2 ammeter will be series and the third ammeter will be attached to the second transformer. This one was 0 to 2 amps and these two will be 0 to 10 amps, and this one voltage across the load will be 0 to 300 volts, and one more voltmeter across the switch to check the polarity of the transformer. Always polarity should be subtractive polarity. If it is additive polarity, then we have to reverse the polarity of the any one of the transformer secondary side. Always it should be a subtractive polarity, means if we had both the voltage, the total voltage should be 0. Then only you can conduct the experiment. So we are going to start the experiment. This is what the AC supply. Directly you can take, supply should go to primary of the transformer. So supply is connecting to primary of the transformer. One more supply I have connected to negative of the transformer. Same supply should be given to second transformer also. So I am shorting from this transformer to this transformer, because supply is same. Supply is same. So I have shorted to which of that's it. So I have shorted both the primary side of the transformer. So same supply is sharing by both the transformer. Next we will come to secondary side of the transformer. Secondary of the transformer, first part should go to ammeter first, that is 0 to 10 amps ammeter. This is what, 0 to 10 amps ammeter. Secondary of the transformer first point should go to 0 to 10 amps ammeter. This is what, 0 to 15 amps ammeter, because 10 amps range voltage there, we have to connect for 15 only. First part. Next, second part of the transformer should go to 3 amperes. Second part of the transformer should go to one more 0 to 10 amps, because both are in series. both are in series. So second part also going to second part. Again one more wire I am taking here. Because it is sharing, one more ammeter is sharing the current. So this one should go to secondary side of the second ammeter, that is 0 to 2 amps. Secondary side you have to connect. From the secondary side of the first ammeter, I am sharing it to secondary side of the second ammeter and primary side of the third ammeter. Next, for this ammeter, 230 of the secondary side of the second ammeter should go to 0 to 2 amps, first side of the 0 to 2 amps ammeter. So ammeter connection is over. Now this 0 of this primary first transformer should go to load negative. Plug. No. Sorry, need some big wire. Zero of the transformer should go to negative side of the load. Negative side of the load, 0 of the first transformer. Next, this 0 should come to second transformer, 0 should go to load. And the load other side should come to again negative of the transformer. Negative of the transformer. Ammeter, third ammeter, secondary side. Third ammeter. Secondary side should go for positive of the load. Positive of the load in the third ammeter. Next, one more voltmeter. Voltmeter first point should come across first point of the switch, because across the switch I have to connect one voltmeter, that is 0 to 600 volts. I am connecting this, and you have to see 600 port only you have to connect. Second port is 600, so I am connecting it for 600. That should connect across this. Then one more voltmeter across load. This voltmeter will connect across the load. Here also I have to connect for 300 volts. This also comes here. 3 wires will come over here. Please be careful while connecting. Should be properly tighted. So this voltmeter across the load, I have connected first point to first point, second point to second point. Now I will switch on. Always before switching on, your switch should be open. Don't close the switch. First I will come again. First supply L to first point and neutral to second point of the transformer. Again from here to here to the transformer I am shorting. This to 0 to 0 I am shorting, and this point should come for the first ammeter, and ammeter other point should go for third ammeter positive, and this secondary part, second side of the ammeter, again we should share. So it is sharing for the second ammeter secondary side, and this part, first part of the secondary transformer will come from the second transformer first side. Again from this ammeter it should go for the load positive side, and this 0 also should go for load negative. Across the switch I am connecting this voltmeter, first point to this and second point to this, and one more point should go for neutral. Now I am switching it on. Now you can observe this. Voltage will be around, this is 600, 440 volts. So it is adding. Both the voltage is getting adding. So we have to switch it off, and we have to reverse the polarity of secondary side of the transformer. I'm just reversing the secondary side of the transformer. Polarity I have reversed because it became additive polarity. Now I need subtractive polarity. So now I am switching it on. Now you have to check. It is 0. You can observe this voltmeter, it is 0. Now I am closing this. Then I have to switch on this load. Now I am switch on this load. 2 loads at a time I have to switch it on. Already 2 loads are on. So I can take the readings. Serial number 1. First here you can see practical values, theoretical values is there. First practical I1 I have to take. I1 you can see here around, this is 1, I can take it as 0.2 amps. I2 is sharing, this is what I2, it is around 0.21 amps, that is downscale, that is 0.56, I2 is 0.56, and this is I3, this is around, this is also around 0.2 I can take. You have to take it fast, so first will get heat. Now you can see here, it is around 3 amps, I1, around 3 amps. This is I2 it is getting reduced because it is dividing 0.25, and this one around 2.8. Same way, 2 more readings. Here you can see here, it is around 4 amps. This is increasing 0.65, 0.65, let it increase, not a problem. This is 4.4, this is 4, this is 0.65, and this is 4.4. Last reading, this is around 4.8, and this is around 1.8, and this one also 4.8 you take. This is also around 4.8. Now you have to reduce it immediately. Then you have to switch it off. These are 2 amps, pause. Yeah, these are the readings. One is 0.2 amps, 0.56, 0.2, 3 amps, 0.25 amps, 28.8, 4 amps, 0.65, 4.4, 4.8, you make it as 0.8. and 4.8. These are the practical values and these are the theoretical values. For doing theoretical values, you have to do short circuit for both the transformers, short circuit test for both the transformers. Okay, first one is transformer A I am taking, second one is transformer B I am taking, so that I will get WS values. While performing, already I have told you short circuit test for 1 kVA and 2 kVA. Short circuit test already I have shown you last class. For 1 kVA it will come Vs around 12 volts, current 4.3 amps, watts around 14 watts. Same way for 2 kVA it will come around 18 watts, 8.6, power also around 18. WS you take it as 20, instead of 18 you take it as 20 into 2 because wattmeter constant will come into 2 you can take. So WSE by ISA square R naught 2 will be WSA by ISA square. This one is A. WSA by ISA square. 4.3 square you will get R naught 2 A. Same way Z naught 2 is VSA by ISA. That is VSA is 12 amps. ISA is 4.3. You will get R naught and Z naught, so that you can find out X naught. Same way for transformer B also you have to find out this, and you have to find out X naught 2. And this is not required. Z naught 2. Yeah, this is required. Cos phi is equal to WL by VL into IL. To find out WL, I can add W1 plus W2, both W1 plus W2. If I add, I will get W12. This is W1 and this is W2. If I add, you will get WL. Then cos phi easily you can find out WL equals VL into IL. VL, no, this is not required. Don't calculate this because I have not given any value, so not required. Don't calculate this. Directly go for I1 value and I2 value. To calculate I1 value, and theoretically you have to fill here I1, I2 and I3. To calculate this I1, what you have to do is I1 equals, this is IL. IL is nothing but I3 here. Whatever the I3 values you got, this one only you have to take it as IL, practical values. First IL value is 0.2. So 0.2 into Z02B, whatever the values you got, divided by Z02A plus Z02B. You will get I1 value. That I1 value you can put here. Same way for calculating I2, IL as it is nothing but I3 value. This formula, current dividend rule, that's it. You will get one value. For I3, you have to add these two, whatever the I1, I2, whatever you got, add this, you will get I3. Same way you have to do for all the IL values. I1 and I2 you have to calculate, and both you have to add I3. Then final answer, this and this should match. Then only your parallel operation will continue. Here 4.8 means here also it should come around 4.78, 4.79, like that it should come. Then only your theoretical value and practical value will match. That is what your parallel operation of transformer. If you complete this, your experiment will complete.